Today with members from Nesta, from the Accelerator Lab, and from Open Seneca. My name is Matias Acosta. I'm the head of exploration of the Accelerator Lab in Argentina. María Verónica Moreno is the head of solutions mapping from the lab, and Lorena, the head of experimentation from the lab. As I was saying, Alex is representing here Nesta today, one of the co-authors of the report that we highly encourage you to read. And Chris here is also with us, who is a member and co-founder actually of Open Seneca. You will very soon hear what Open Seneca is all about. But now, let me start by sharing my screen and telling you a story, how all this started. And this was actually all because initially of a false bomb alarm that took place in Cambridge, and Norberto, who you can see actually on the left side of the screen, and he's actually here today. So it was obviously a false alarm because what the police thought was a bomb was actually a research project with low-cost sensors, air quality sensors, such as the one that you can see in the right-hand side of the screen. But this false alarm had an important consequence. The UK news became viral, and it traveled all the way down to Norberto, who was in Argentina at the time. Norberto is a civil servant working in environment in the government of Argentina, and he cares about air quality because our country has little to no information about it. And this has to do actually with the high cost to measure air quality, costs that come from the standard stations, as well the standardization process and the monitoring calibration process requires for it, as well as there's other issues related, for example, to outdated legislation in our country. And not knowing about the air quality, it's a major issue because, for instance, and to put it in perspective, WHO has estimated that around 7 million premature deaths could be attributed actually to the low quality of air that we breathe every year. And yet in Argentina, we know little about it. So this is how our journey for citizen science for environmental policymaking began. But now at this stage, you may be wondering what is actually citizen science. And believe me, you don't have to worry about it. We do get asked this question quite often, particularly by policymakers. So simply put, imagine that it is a discipline or a set of activities that are centered around issues or knowledge creation. And it generally follows a rigorous methodology that could be done entirely by citizens themselves, or very often actually through their collaboration with scientists. Now, as we learned before you were hearing in the talk, collective intelligence is an enhanced way of mobilizing information and insights thanks to people working together, right? So for us, citizen science is collective intelligence in action. And this is because it can bring together citizens, it can bring together scientists, and it can bring together policymakers, such as, for example, Norberto. And Norberto and Open Seneca basically starting working on this project back in 2019. But then the pandemic hit us at that time, and things got complicated because of the lockdown in our country. But instead of just sitting at home, what we decided was to see that challenge as an opportunity to evaluate a baseline of air quality during the lockdown. And this opportunity called the attention um, of basically the National Ministry of Environment and the city of Buenos Aires government that's supporting the expansion of the project and began working with us. And this is why we decided to talk with Chris to take part in this collaborative project. Right, Chris?
Exactly, Matias. So before the lockdown, Open Seneca held 2 workshops at universities in Buenos Aires with more than 100 students assembling our air quality sensor unit. We specifically designed our sensors to use open source hardware, which is ideal for like an educational do-it-yourself assembly with citizens from literally all walks of life and to complement the local know-how. Our first workshop was at the Ciudad Universidad de Buenos Aires, and the second one with Open Seneca, we held 2 workshops at universities in Buenos Aires with more than 100 students at the time who assembled the air quality sensor units. We designed those units very specifically to use open source hardware, which is fantastic for like educational do-it-yourself assembly with citizens from all walks of life, and to complement like the local know-how. The first of the 2 workshops took place at the Ciudad Universidad de Buenos Aires, and the second one was at Universidad Nacional General San Martín. And we began each workshop with an hour-long presentation about air pollution and had a particular focus on its implications on climate change and health effects. After the presentations and a brief introduction to the electronics that we used, the workshop then like truly developed into a more practical hands-on session in which teams of about 4 to 5 students were formed, and each team was given a sensor kit to assemble and test. And we found there that the students were very keen and enthusiastic about the hands-on work. The end of the workshop was then a live demonstration of data acquisition by taking one of the just assembled sensor units around the block and displaying a live stream of the data that this very unit recorded into the lecture theater. So now we had essentially 20 volunteers cycling with our sensor in Buenos Aires, and among them were, for example, David Usher, who's the Canadian ambassador to Argentina, and Mark Kent, who's the British ambassador to Argentina. And from this experience, we identified like very valuable opportunities for research and potential for educational insights. Then after the initial deployment and with the start of the pandemic in early 2020, we started working together with the Accelerator Lab to measure air quality with volunteers from the city of Buenos Aires government. And the goal at this stage was to compare the data that was collected previously with the data that was collected during the COVID lockdown to sort of understand the effects the lockdown had on local pollution phenomena. And we got some preliminary yet quite detailed results, isn't it, Matias?
Indeed, actually, we did, Chris. So what we observe here, it's a Google map. We have million data points of air contamination in the city of Buenos Aires. And particularly, we are seeing particulate matter, which is a crucial contaminant in air for our health. Basically, it's quite critical. And what the colors tell us is that every spot that is yellow, orange, or red, it has a contamination that it's locally exceeding the safety limits recommended by WHO. And for instance, you can see at the left side of your screen up here a magnification of a red spot. So what you see, it's an intersection of several streets that has a high local concentration of particulate matter. Now in this slide, you see a cluster of data comparing results before and during the lockdown or throughout the lockdown. And we're still evaluating actually further the data and using different models to understand what does it mean, this localized high concentration of or contamination spots. Let's say that you can see that they differ quite substantially actually from the mean, let's say, air quality of the city. And indeed, this matters for strategic urban design because it's the localized air that we as people are breathing. But in addition to this learning question, we are also scaling the solutions. The sensors have been by now deployed also in the cities of Mendoza and Cordoba. And we are also bringing 10 new sensors to begin doing measurements in the north of our country. And we began conversations also with the Ministry of Environment to bring like even further new sensors to compare the air quality of different states of our country simultaneously. And use this data actually as a way to promote further a new air quality legislation. But citizen science is much more than technology and data. What we also found is that volunteers that participated in the experience became quite excited about the topic and about sharing information of air quality, as well as they recognize its importance, let's say, for our health as well. So we really saw an opportunity with this project, a new door for supporting policy using a collective intelligence approach, as I was mentioning, which many times can be actually powered, as you can see here, by open hardware, and can lead to even real-time environmental monitoring. But you know, not every project has the luck of becoming, let's say, viral in the news. So we needed to actually try to dig out which were those under-radar citizen science projects in our country that could support policymaking. Don't you think, Vero?
Vero is joining,
we...
and she later is going to tell you more about this solution she has mapped in alliance with the Ministry of Social Environment, and also the Ministry of Science and Technology. And while she joins us, I can tell you more about how we plan to scale it. Okay, so we were discussing with Matias and with Verónica some interesting patterns we found across different solutions that hopefully we are going to share with you later. And in fact, these patterns from different solutions appear as lessons that illustrate the power of citizen science as an exercise of collective intelligence in action. First of all, citizen science can reinforce environmental activism when volunteers support gathering real-time environmental information for policymaking. It can also bring new insights in the public agenda and help assessing environmental impact. And beyond their quality project, the mapping of different solutions show that these experiences give people the chance to advocate for new issues overlooked in the public agenda when their concerns are left behind. Moreover, citizen science also gives the government the chance to co-create new solutions, bringing non-conventional sources of learning to well-known problems. In this process of co-creation, citizens get involved and engage more with the making of evidence to inform policies. And last but not the least, when people became aware of the causes of their problems, they often change their behaviors. All these inputs are crucial to accelerate our knowledge of complex problems hampering development. However, we see there is a last mile problem by which most experiences fail to reach the state. So we are going to test, this is the reason why when we decided what to test, we focused in a solution that was very successful, bridging citizen science with policy making. We are going to test this model that merges citizen science with decision makers on regular basis to solve crucial problems such as floodings, with the support of Joaquín Coachero, who led other very important projects. This may seem obvious to you, but we could only find a single citizen science example that connected successfully with policymaking in our country. And that is the reason why we are designing this experiment in which we are going to promote an action varying the level of participation of citizens and scientists to compare the result of these experiments in policy outcomes in different municipalities. What we want to test is whether this model is applicable in different contexts to scale citizen science for policy making. So it seems now the circle closes from the very single action on air quality to the whole loop of learning on citizen science, thanks to collective intelligence. Isn't it, Mati?
Indeed it is. And actually, you know, before we go into this further scaling, we need to show you the solutions, right? And what's going on in our ecosystem. So Vero just joined us. So we overcome the challenges. We are here now. We can show you the solution.
Things happen. Yes. We took this air quality project as an opportunity to start mapping other citizen science projects in Argentina focused on the environment, because we realized that it generated great interest in different stakeholders. For example, when we talked to Alex from Nesta in the process of making this collective intelligence report, we understood that our lab could contribute to making the Argentine citizen science ecosystem well known in different places. In fact, we presented a poster with some preliminary findings from our solutions mapping phase at the annual event of the Citizen Science Association. If you like, you can download it from the QR code in this slide. Moreover, we have partnered with the National Ministry of Science. Together, we have been co-creating the mapping strategy. We have already mapped more than 20 projects from vector-borne diseases to environmental monitoring. In this slide, you can see pictures from 3 different projects. Mateada, which is a mobile app to study rivers, lakes, and lagoons, and it also provides this wage watch. This initiative citizens and the last is Vuela.
Vero, we're using you. Can you maybe
a toolkit for open science with drones?
Can you maybe shut your video so we can hear you better?
So I think we have a problem with the connection. So what I can do is I can briefly share about these 3 solutions, which are among over 25 that we actually so far mapped and validated around the country. So Apear, it's a mobile app to study rivers and lakes and lagoons, which provides an opportunity for establishing discussion forums. Are you there?
Yes, I'm back.
You can go ahead.
Today
you can go ahead.
From...
I was reintroducing
okay.
Apear.
Okay. And Apear is a mobile app to study river, lakes, and lagoons, and to provide discussion forums and generates educational resources. The other one is Observa Residuos, Weight Watch. In this initiative, citizens sort, weight, and report the quantity and composition of their domestic waste on a digital platform. And the last is Vuela, Fly, which works with a prototype toolkit for open science with drones to tackle local problems, equally accessible to marginal communities, activists, or researchers. And let me tell you something, we are excited. This mapping exercise will be a basis of a national bank of citizen science projects in Argentina. So we are mapping and scaling at the same time because the project will map beyond environmental projects. We are also confident that these solutions can provide innovative responses to public policy challenges. And we are not alone in this belief. We have been bridging some water quality projects with the National Ministry of Environment, and they were amazed by them. Some of these projects have already designed the tools that civil servants have been dreaming of, and that's what mapping is all about. Because we have mapped several innovative projects, now we are discussing how to experiment with these solutions. And I guess that Lorena told you that before.
Indeed, actually, so Lorena was sharing with us some of the experiments, opportunities that we have and how we are focusing on these. I mean, as you learned today, actually, you know, with Accelerator Labs, learning means also action and taking fast decisions. So we are already prototyping another citizen science project together, for example, with the municipality of Bragado, that it's about quantifying the city, the vegetation, the urban vegetation in their city, in order to promote further urbanistic policies. And we are certainly as well learning from the process, and as I was saying, taking action. So as you can see, basically these learning and action cycles for us are a way to engage in non-conventional methodologies for development, as well as bringing new partners that can accelerate it. So we discover basically that citizen science, it's a collective intelligence strategy in action, and it is a way to leverage technology and citizen participations to enrich the process of policy making. So we found it's a great way actually also to bring together citizens, scientists, and policymakers. Um, and that's why basically we invite you to learn more from this experience and also from others in the collective intelligence report, as well as if you can share with us to keep on expanding this collective intelligence approach, your own experiences, would be very happy about that as well. At this time, I would like to thank you very much indeed for your attention, and we leave the floor open for questions or a conversation. Thank you. And I will stop sharing a moment so we can see our faces as well. Is there someone, perhaps, feel free to either unmute yourself perhaps, or share your
There are some
questions
questions
if
in
you
the
wish.
chat already. Maybe some of you want to jump in and share your questions.
Actually, I want to say you something. Like in Europe and all, we are stopping plastic, stop using plastic. But I want to say that why can't we use biodegradable plastics?
So so the question about this, Don?
Why can't we use biodegradable plastics?
So far, in let's say in our experience, we didn't deal with any particular citizen science project that is discussing about the use or not of biodegradable plastics. Perhaps if you know one about it, we can discuss it further and analyze it. So I wouldn't have basis now to comment further.
And I have one more thing. If it is COVID, why can't we spray antidotes when everyone is in home?
Sorry, I didn't catch that question. So
Why
perhaps
I'm not hearing very well.
Why can't we spray antidotes when everyone is at home?
But perhaps I mean, we cannot hear you very well. Perhaps you could chat, you could send in the chat your questions, and we can continue with other questions in the chat as well.
Yes, here is a question from Sahil. How you remove bias from data to make it inclusive?
That's a very, very good question. Perhaps, Chris, you would like to comment something on the approaches that Open Seneca is doing for this, or we can comment further from the experiences that we have, perhaps from some solutions.
Please go ahead. I was wondering what kind of bias he meant, actually. So maybe he can specify. That'd be great. But please go ahead, Matias. Yeah.
Okay, so I feel, Vero, if you have some comment, you could go ahead after. I will just provide some inputs from some of the analysis that we have been doing in the exploration. So I think that the bias indeed can have several dimensions. So one, it could be, for example, about the people involved in the citizen science project. If you have, let's say, similar type of stakeholders involved, you can have a bias in the results, because those stakeholders will likely have a similar view of that phenomena that you are investigating. So in that particular case, what you should consider, therefore, it's having a diverse audience, which would be, and diversity in that particular case would be correlated with the type of project you are doing. Now, there could be biases as well, for example, in terms of geography. If you are comparing, for example, air quality, and you are measuring only in a particular area, for example, that has a higher pollutant content than other area, you could also be biasing overall the information. On that, what you should do is try to basically have a broader spatial and temporal type of data or information as well. So those would be, let's say, two approaches that one can use in order to evaluate, let's say, different type of biases. I hope that's supporting or answering the question.
Here's another from Shivam,
Yep.
Matias. If the sensor is at the bicycle, would that mean that we are measuring air quality close to the pollution source? Maybe use land use info to make it more concrete? And also, Jimena, feel free to share your questions in the chat. We are going to check them all.
I think, Chris, you could answer about the details, let's say, of why and where the sensor is located.
I did in the chat, but I can just do it again. So what we measure is actually like personal exposure to air pollution. And the reason for choosing a bike is just that very convenient and it covers a lot of area in the city. I'm not sure what was attended with the question regarding to land use. What I can comment on is though, because you're probably pointing towards single pollution events, those are filtered out for our air pollution maps, and we can sort of avoid that a hotspot is mistaken where there's actually none. I've read before about land use models that are very interesting in that context, but we have not very much explored that possibility so far.
Perhaps one thing I could also share about the first experience with the sensors, we actually also, on top of having those sensors on bikes, we also left some sensors next to calibrated, standardized stations to evaluate, let's say, how they were, or the data that they were acquiring, how was it compared to, let's say, more advanced measuring technologies. And we could actually therefore do a sort of co-calibration with that as well. That could help us understand a little bit further the accuracy of the data that was taken from the bikes or while the bikes were riding.
Here is another very interesting question on how the assembly of the sensors are documented in order to be able to scale it in other countries or in other experiences as well.
Yeah, so Chris, would you like to share that, or I could also comment something on this, but
go ahead if you want. Yeah, all good.
So basically at the time what we created, it's sort of educational type of kits. So we did this together with Open Seneca, which is an easy do-it-yourself step-by-step type of educational material. And well, Chris can perhaps communicate that, but for example, now Open Seneca has been expanding to other countries as well. So Chris, you can say if you want something about that, on how that expansion happened and whether you are taking these kits, let's say, further.
Yeah, so indeed, as Matias said, we fully use open source hardware with open source code. So it's very easy to replicate and scale the project elsewhere. It's also very easy to assemble, like the sensors that we are currently building take about 10 to 15 minutes to assemble by yourself by just following a video instruction. And so it's very easy to scale and wherever you are really, as long as you have the hardware.
An important aspect also is there's always a quality control after, right? Like before the sensors will go and measure as well. So I think that's
of course, yeah. It's like the calibration step that you just introduced that is very important to sort of guarantee that the data matches like certain data or quality standards.
Well, thank you so much, Chris. There are two very interesting questions from Ulises Pachares. First one is, how do you engage citizens to participate collecting data? What is their demographics? And also, which is the biggest challenge that governments face when integrating collective intelligence into their programs?
Those are very, very good questions indeed.
I don't know if Vero wants to reply some of these questions. If not, I can jump in.
Yes, of course, I can. I have very bad connection. Could you please repeat the question? So sorry about that.
Yes, of course. How do we engage citizens to participate in collecting data, and what are their demographics? Actually, during the lockdown, they were bureaucrats, but I thought you can share a more general.
Yes, there are different. Yes,
challenges
there are different. Okay, that's fine. There are different strategies to engage community. There's not a single recipe that works for every project. So it depends on the objectives. Sometimes when the problems are local, the project leader try to start with the definition of the problem, and that's a way to engage community. So start thinking together. It's really collective intelligence in action to start by defining the problem, which is the problem, and then the strategy and how to collect data. This is for us, from what we map, this is like the great way to engage communities. And I can add something there, that when you're working with marginal communities, it can be problematic to treat them as volunteers. So sometimes you have to compensate their time and their efforts. And this is other way to engage them and to recognize their efforts in the projects.
Thank you so much, Vero. And regarding the second question, I think one of the main challenges is that actually governments are not very keen or don't find easy to integrate the result of citizen science directly into their programs. This is the reason why the best model we found regarding this integration was one in which scientists, which are usually who foster citizen science, were already integrated in the government. I mean, there are a lot of citizen participation in government programs. We saw it and we encourage it, but sustainability must be a challenge, and how these inputs translate in actually policy interventions is a bit difficult. And this is the reason why we are working to leverage this integration.
Yeah, you're right.
So I think we have more time. There are more questions here.
While we dig out, there's a lot of comments coming. So while we dig out for a new question, I could add something also to Vero.
Absolutely.
To Vero's comments about communities. What we also saw is sometimes actually you don't need to engage yourself as a project organizer or coordinator, perhaps the community, because the community itself is already organized, and sometimes they push themselves some citizen science project. So there are also these more like community level driven projects as well. So you have a different mix of solutions which are interesting, and therefore there is different strategies based on that, on how to interact.
Yes, they're really different. It depends on the projects and how it works. Yeah.
Yeah. So we have 20 seconds.
Yes. We thank you so much for your participation. We hope you can be in touch with us and follow the progresses of our loop of work in citizen science as a collective in action, collective intelligence in actions tool. Thank you so much.
Thank you
See you
so
in the
much
main
for
room.
joining.